Welcome friends. In today's lecture of metrology, we are going to discuss limit, fits and tolerance. Let us start with the fits, clearance fit. If the lower limit of hole is greater than the upper limit of shaft, in that case we can say that there is a clearance fit. In the coming slide you can easily see what is the upper limit of hole and lower limit of shaft. Let us say these are the pictorial representations of the hole and shaft. This is the baseline, right? Here you can see that this is the baseline, basic line also it is called, and this much is the tolerance of hole. That means this is the lower limit of hole and this one is the upper limit of hole. That means the dimension of hole will not be more than this upper limit. This is a tolerable, what I can say, deviation in the dimension of the hole. So similarly for shaft, here you can see, if let us say this is our shaft, either this or this, we will talk about this. This A is the fundamental deviation and this horizontal line, upper horizontal line is the upper limit of shaft and this one is the lower limit of the shaft. I think it is clear to you. So we'll move to the next slide. Hope you are clear with the upper and lower limits of the shaft and hole. There's technical glitch, just a minute. Yeah. Here, if there is a, what I can say, this yellow portion is the overlapping. That means the upper limit of the shaft is overlapping to the lower limit of the hole. That means if any shaft, let us say a sample or a bunch of 1,000 holes and shafts is manufactured and any one of it having a upper limit of shaft more than the lower limit of hole, then that assembly will not be possible easily without the heat treatment, let us say. So this is the overlapping portion and this is called the, what we call it, clearance or interference or transition. Clearance will be there only if there is no overlapping, but here you can see there is a overlapping. So this is not clearance fit, first of all, right? And clearance will be like this, clearance fit. Here you can see there is a gap in the lower limit of hole and upper limit of shaft, and this much is the clearance. So we will call it as a transition fit. Here you can see there is a transition, neither the clearance nor the interference is there. In interference there is complete overlapping. Let us say shaft will be somewhere here. I will show in this case. This is the complete interference. The size of hole is lesser than the size of shaft. So the assembly will not be possible without the heat treatment. So let us discuss this example of transition fit. Here you can see the upper limit and the lower limit. This is the basic line showing the dimension of 50 mm. This is the upper limit of shaft, let us say equal to 50.05, and lower limit of shaft is equal to 49.79. The complete tolerance on the shaft is 0.05 mm. Now, same example, if 1000 holes having dimension between 50.01 to 50.05, that means this much is the variation in the different holes once it is manufactured. Let us say we have given order to particular another company, and we have mentioned that this much is the tolerance which will tolerate, except that if there is any deviation, we will not accept such part. Right. Now, here you can see if the lower limit is 50 and upper limit for hole is 50.05. Now, some shafts are there having dimensions, let us say 50.01 to 50.02, which is falling in this range. Now, if our upper limit is greater than the lower limit of the hole, that means the upper limit of shaft is greater than the lower limit of hole. Here you can see there is overlapping. Such particular pair will not able to make a assembly without heat treatment, or any other external force or forceful assembly may be possible. Such type of assembly you will see in gear, pulley on shaft, where there is a transition fit is required. So there should not be any clearance, nor there should be a play, or the pulley or gear should not rotate on the shaft. In such conditions, we will use the transition fit. Clearance fit is very easy to understand. Here itself, from the figure you can see it. A hole is specified as 40. Upper limit is 0.05, lower limit is 0.00. That means lower limit is itself 40 mm. The mating shaft has clearance fit with minimum clearance of 0.05 mm. This is clearance is given 0.01 mm. The tolerance on shaft is 0.04 mm. This is tolerance of shaft. What is the maximum clearance? Maximum clearance is this one. That means the upper limit of hole minus the lower limit of shaft. By doing this calculation, we will get the maximum clearance. Just you have to add this tolerance, clearance, and the tolerance on hole. That means both the tolerance on shaft and both tolerance on hole plus clearance. We will get the maximum clearance. One question is given here. So look at the question. An interference assembly of nominal diameter 20 mm is to be made between hole and shaft. What it is given? Interference assembly of nominal diameter 20. That means one diameter is given, nominal diameter. Tolerance on hole is twice that on the tolerance of shaft. Shaft tolerance and hole tolerance, the relation between them is given. Tolerance on hole is twice that of the tolerance on the shaft. Possible interference values are 0.03 mm and 0.09 mm. Determine the size of hole and shaft. The case may be like this. Let us say we have given the tolerance on hole, that is let us say T1 and tolerance on shaft is T2. T1 is twice that of the T2. T1 is equal to twice T2, let us say. This case may be possible, or this second case, shaft 2 hole 2 case may be possible, and again this case 3 hole 3 and shaft 3 can also be possible. But what we have given that the tolerance on hole, yeah, it is satisfied itself. Possible interference values are 0.3 mm and 0.09 mm. Determine the size of hole and shaft. Right. So we will draw this assembly. We will take X as the tolerance value, so that we will get the relation between tolerance on hole and tolerance on shaft. Here you have you know that twice X is the tolerance on shaft, twice the X is the tolerance on hole. Very first we will nullify other two cases. Why this? We are taking this example only. We will see. We have given interference. That means the interference can be in this case also, there in this case also, or in this. All three cases are of interference, but given is that the tolerance on hole is twice that of tolerance on shaft. This is also possible in all three cases. Then third case is given that possible interference value are 0.3 mm and 0.09 mm. That means there should be interference. Here you can see in the figure there is a interference. That means this much should be the interference. When it is possible, when let us say this is 0.04 plus 0.03 plus 0.02, what will be the total value? Maximum tolerance or maximum interference is 0.09. It is satisfied in this case, and the minimum is 0.03. Both the conditions are satisfied in this case, while in other case, is it possible? Here it can also be possible, and here also it can be possible. So we are taking any one from this, right? First case we have taken. Now we will solve. Once we have got the values, here the lower limit of hole will be itself a 20 mm, that is in nominal diameter baseline. Upper limit will be the lower limit of hole plus the tolerance on hole, that is 0.04 mm. So upper limit is 20.04 mm. Similarly for shaft, lower limit of shaft is baseline, that is the nominal diameter plus the tolerance on the hole plus the minimum interference value. This complete will give the lower limit. That means this distance plus this distance, we are getting the value for lower limit. That is, this is the lower limit. This much complete distance we are getting by adding this 20, that is the basic line, plus this tolerance, plus this interference. By adding these three, we are getting this. Again, by adding this much distance, that is tolerance on shaft, we will get the upper limit for the shaft. Here we have calculated it at upper limit. That is the complete maximum interference we will add to the baseline. moving forward, so we will discuss now the hole and shaft assembly, different cases for that, how the designation is done. This is the hole and shaft assembly designation. Capital letters are used for the whole base system, A, B, C, D, all 26 letters, plus the combination, let us say C, D, E, F, like this. These 28 types are there for designation of whole base system, provided all should be in capital letters. This is the fundamental deviation shown in blue color. From the baseline there is the deviation, you can see it is called fundamental deviation. So similarly for shaft, how there is symbols, how symbols are used and written. The small letters are used for the shaft designation or shaft base system. A, B, C, D small letters. Similarly here also C, D combination of two letters can be used. If small letter is there, we should consider it as a shaft basic system, or if capital letter is used, it is a whole base system. The very first number in this complete designation indicates the basic size in millimeter, right? The second here itself, the capital letter is telling that this is a hole tolerance zone, that is hole tolerance zone, and the capital letter is nothing but the fundamental deviation of hole, and this is the international tolerance value 7, that is IT7, and as it is the suffix of capital H, so it is the international tolerance of hole. Now next one is the small d suffix 8. This is the shaft base, right? If small d is used, 8 is the international tolerance for the shaft. So we will find the tolerance values from one chart. I will show that chart to you people very first. Where it is, yeah, this chart, this is the IT8, that means the international tolerance 8. For that, tolerance value is 25i. 25i, that it is in terms of ki. If t is equal to ki or equal to 25i, that means k value is 25, and I, there is a empirical formula. From that we will find the I, so we will get the tolerance value. Now we will see the value for finding the formula for finding I. Here is the formula for finding I. So we will put this I value, after getting I value, into this formula for T tolerance Ki, and we will get finally the tolerance value for each shaft as well as for hole. Those will be different if different suffix are present to the hole and shaft. Now you can see that this I formula contains capital D. This capital D is equal to under root of D1 D2. How this lower D1 diameter and D2 higher diameter we will get? These are the diameter taken from the diameter step, which is also given in one table. If question is asked, don't worry, the values for these steps will also be given as well as the just you have to keep in mind the formula for international tolerance. Let us say if our given designation is 20, capital S 7, small d 8. That means this diameter falls in the range of, here you can see 18 and 30. So we will take 18 as lower diameter, and that is equal to D1, and 30 as higher diameter. If 30 itself is a given in the designation, let us say, then what we will do, we will consider that 30, here you can see this 30 as a maximum diameter or higher diameter equal to D2, and lower diameter than that in this table is 18, so we will keep D1 equal to 18. So from here you have got the value for capital D. Just now put these values into I and T, get the value for tolerance. Here we will put the value of D. This value will come into micrometer. Every time keep in mind, even though these values D1 and D2 are in millimeter, the final value for I in the same formula will get in micrometer. Just put this value of I and K, you will get the value of tolerance. This how to keep in mind this table. You can remember this like this. You can see these arrows here. First row you have to, column you have to keep in mind just IT5, IT6, 7, 8, 9 like this. These are in increasing order. IT5 is 7i. No doubt this chart will also be given, or either the IT value will be given. But for your information, how to keep in mind that first value is 7i, 10i, then 16 and 25. Just these four values you have to keep in mind. After that, and this fifth one, 40i. So you can see the next value, or the arrow is showing the multiplication factor of 10. This is 40i, here it is 400i. Similarly, here is 64i, here 640. That means 10 times. If here is 10, here 100, here 1000. Now this is 16 and this is 116. That is 10 times. That means this 5, 6 values first you have to keep in mind. Here this 250 is also taken from this 25, 10 times of the 25. So you will get the values of K and the tolerance value T. Here is one example. Let us see. Determine what it says. Determine the dimension of hole which is designated as 25 capital H base 8. That is suffix 8. 25 capital H 8. Basic size is 25 mm. Hole base system it is, because capital H is given. So this is the base diameter of the lower limit of the hole. Now, as this 25 falls in the range of diameters 18 and 30, so D1 will be 18, D2 equal to 30. Recently we have seen that table. Here we have got the value for capital D. This will be in millimeter. By putting this in this formula as it is in the millimeter, you will get the value for I in micrometer. So by putting this value of I in our tolerance Ki value, that is T is equal to Ki, we will get the tolerance value. You know that K is 25 25 for the international tolerance 8, IT8. So here we have got the value of tolerance for the hole. This is the complete value. Now lower limit of hole plus, here you can see lower limit of hole plus the tolerance value, we will get the upper limit of the hole, and this is the upper limit, that is 25.0326. That was all about the limit, fits and tolerance and the designation of the hole base, hole and shaft assembly. So if you have any doubt, write in comment box. Thank you for watching this video. Also don't forget to like, share and subscribe our channel for getting such information or fruitful videos for your preparations. Thank you very much once again. Signing off for the day.